Accelerated algebra 2 stirrup here. So this is 6H, factoring polynomials and solving polynomial equations. So we're going to focus on sum and difference of two cubes, which is, we already know we have difference of two squares, but this is going to be a little different. Okay. So if I wanted to, I'm not going to worry about what is written up there. I'm not worried about this right now. We can talk about it in class. The general equation for if you have two perfect cubes, so remember your perfect cubes, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 27, 64, 125, 216, 343, let's see, 2, 3, 4, 5, 6, 7, 8 times 8 times 8 is 512, 9 times 9 times 9 is 729, and then 10 times 10 times 10 would be 1,000. So those are like the first 10 perfect cubes. Okay, so we have to know that. So if A is a perfect cube and B is a perfect cube, this is going to be the general form. So that's how it factors. If these are both perfect cubes, and it's the difference is going to be just two signs are changed. Everything else is the same in the equation. Okay, so notice that this sign and this sign and this sign and this sign are flip-flopped. That's the main thing. Okay, so we're going to kind of use that model as we go. All right, use our pattern graph. So again, this is going to be a to the third plus b to the third. So we're talking, we have a plus b, and a squared minus ab plus b squared. So my a term will be x, and my b term would be 4 because those are both perfect cubes. So I'm going to get x plus 4, x squared minus 4 times x, because it's a times b, plus b squared, so 4 times 4 is 16. And that's factored. Okay, remember if I had the subtraction, it's going to be a minus b, a squared plus ab plus b squared. Okay, so again, my a value, we're going to let that be x. My b value, we're going to let that be 5 because 5 times 5 times 5 is 125. So I'm going to go x minus 5, and I'm just plugging into my equation. A squared is x squared plus a times b, so 5 times x, plus 5 squared. Done. This next one is going to be utilize this top equation. So a is going to be equal to x, b is equal to 6, because 6 times 6 times 6 is 216. So I'm going to get x plus 6, and then times x squared minus x, or a times b, which is 6 times x, plus 6 squared, which is 36. Okay, pretty straightforward, huh? Just kind of remembering the equation it goes with. So difference of two squares. Well, remember difference of two squares just factors like this, and that we've done that since algebra 1. Okay, but let's say I had something like this. So we could look at this being x squared minus 9 and x squared plus 9. Okay, x times x is x to the fourth. They're conjugates, so the outside and the inside cancel each other out. And then negative 9 times 9 is negative 81. This right here is difference of two squares. So a lot of students get stuck on this problem. They take it to this point down here, but they don't have to realize that this is the difference of two squares here. And then we don't have a sum of two squares. So this just stays like that. Okay. How would we do this? Well, that's going to be x squared minus 1 and x squared plus 1. So again, if I FOIL this out, they're conjugates, so the outside and the inside get rid of each other. This is still the difference of two squares. And then the sum of two squares does not exist. How would I do this one? Oh, well, you have to realize that 5 times 5 times 5 times 5 is 625. Okay, so I'm going to get x squared plus 25 and x squared minus 25. And x squared minus 25 is the difference of two squares. So this stays as is. It looks like that. And that's, make sure you factor completely. Difference of two squares. If it comes into your problem, it'll be there. All right, factor completely. So again, we're going to realize we have x squared and x squared. We're factoring them like normal. What two numbers multiplied to give me negative 15 add to give me positive 2. And I'd say it'd be positive 5 and negative 3. And that's as far as we can go, because this is not the difference of two squares, because 3 is not a perfect square. You can't go any further than that. This one I would factor a 2 outside first. Plus 9. Is that right? Oh, you know, if I could factor correctly, I'd be a really better teacher. My grammar's horrible now, but you all knew that. So that's going to factor down to x squared minus 9 and x squared minus 1. And you notice that it factors down to difference of two squares. Okay. So what if we were to set each of those equal to 0? Well, let's look up above. X squared plus 5 equals 0, and x squared minus 3 equals 0. So this would be x squared equals negative 5. So x equals plus or minus I root 5. So we have an imaginary term there. This one I'd add 3 to both sides. So that's a 3. Take the square root of both sides. So you get plus or minus square root 3. So that's a real answer. This is an imaginary answer. And then same with this. This would yield me x equals negative 3, x equals 3, x equals negative 1, and x equals 1. Okay? So this one gives me a whole bunch of real answers, meaning it's going to cross the x-axis. This would cross the x-axis. This would not cross the x-axis. All right, find all the real solutions. So the first thing I'm going to do is I'm going to factor 3x out of both. So 3x is equal to 0. X plus 2 equals 0. So x equals 0 is one answer, and x equals negative 2 is another answer. On this one, that's the difference of two cubes. So I'm going to remember, I'm going to let my a value equal x, my b value equal, let's see, 512 is 6 times, what is 512? Sorry, my mind just drew a blank. That's 7 times 7 times 7. 8 times 8 times 8. It's 8. Sorry. I don't know where my mind went. Excuse me. So I have x minus 8. And then I get x squared plus 8x plus 64. Okay, so this is going to get me x is equal to 0. This one makes complex solutions. So we could do a couple of different ways. If I were to use the quadratic formula, and I'm just kind of skipping some steps, 4ac all over 2a, 2 times 1. Is that 64?
That's by her new method.
I'm recording, but it's okay. You guys can talk. You're good. Talk, you guys. You're not interfering with me. So that gives me negative 8 plus or minus I root 192 over 2. And then you could break 192 down. So this would give us an imaginary answer. So if you break 192 down, it would break down a little bit more. Okay? All right, so this one, make sure you bring that 90 over, the 90x over. Factor out x from everything. So this gives me x equals 0 as my first one. That takes care of that. This will factor to x, let's see, does that give me, see the factors of 90, 1 and 90, 2 and 45, 3 and 30, 4, 5 and 18, 6 and 6 and 15. That works. So x minus 15 and x plus 6. Set those both equal to 0, so I get 15, and I also get negative 6. So I have 3 solutions to this problem because it was raised to the 3rd power. Next problem, I'm going to factor 7 out. So my a value is going to be equal x, my b value is going to equal 1. So I get x plus 1 times x squared minus 1x, or just x, plus 1. This is going to give me an answer of x equals negative 1. But this one is not going to factor, so quadratic formula. What is that? Root 3 over 2. So my answers to the second one are 1 plus or minus I root 3 over 2. So this is 2 solutions, and this is 2 imaginary, or 2 complex, and this is 1 real. And again, we have 3 solutions because of that's raised to the 3rd power. Okay. All right. Just take care of the odds on the homework. We'll meet in class, talk about anything you have questions on. Have a great day, everybody. Bye-bye.